Okay, you're all welcome to this meeting. The questions that we are going to discuss are going to be shared in the Math Up WhatsApp group, but are also going to be shared in this chat. So please stay tuned for that. I think the questions should be shared first. Then we can begin so that we can follow together. I hope you can all see my screen. If there are any questions, feel free to raise your hand. I also hope I'm very audible and that you can all hear me. So the first question in the seminar is this. This is going to be a seminar on coordinate geometry, so the questions are going to be on coordinate geometry. Question 1, A and B are the points, -1, -6, and 5, -8, respectively. Which of the following points lie on the perpendicular bisector of AB? So we have these points on a Cartesian plane, and we want to figure out which of these points lie on the perpendicular bisector of those 2 points. So it could be more than one of the points that were given that lie on the perpendicular bisector, but we want to find out which ones. So we could do this in a number of ways. And one of the ways we could do this is using the fact that for points on a perpendicular bisector, they would satisfy the equation of the perpendicular bisector of the line segment. So we know that the midpoint of the line segment is going to lie this perpendicular bisector, and the perpendicular bisector is going to be perpendicular to the line segment. So we can easily get its equation. So first we'll get the coordinates of the midpoint of AB. So coordinates of the midpoint. We just get the average of the coordinates of the ends of the line segment. So the coordinates of the midpoint would be -1 plus 5 over 2, comma, -6 plus -8 over 2. And that is 4 over 2, which is 2, -7. So those are the coordinates of the midpoint. Now, how do we get the gradient of the perpendicular bisector? Now, the perpendicular bisector is perpendicular to the line segment. So if we get the gradient of the line segment, then we can easily get the gradient of the perpendicular bisector. So the gradient of AB is going to be change in y over change in x. So I could do -8 minus -6 divide by 5 minus -1. Realize that this is going to be -2 out of 6 is -1/3. So you know that for perpendicular lines, the product of their gradients is -1, right? So that means the gradient of the perpendicular bisector of AB is going to be -1 divided by -1/3, and this is 3, because the product of the two gradients should give you -1. So now we have the gradient of the line whose equation we want to find, and we also have a point on that very line. So we can use, if we use y minus y naught out of x minus x naught is equal to m, this relationship for the gradient, then we would have y minus -7 out of x minus 2 is equal to 3. So this is y plus 7 is equal to 3x minus 6. So you could have this as y is equal to 3x minus 13. So this is the equation of the perpendicular bisector. Now you want to check, okay, so which points do I have that satisfy this equation? So you could check first with point P. So for point P, if I substitute in the right hand side, for point P, 3 times 3 minus 13 is equal to 9 minus 13, which is negative 4. So I have the 3 and the negative 4. So point P actually satisfies the equation of the perpendicular bisector. So it should be on the perpendicular bisector. If I check for Q, 3 times 4 minus 13 is 12 minus 13, which is negative 1. But this is not equal to 0, right? The point we were given was 4, 0. So this does not lie on the perpendicular bisector. I could also check for point R. Point R, 3 times 5 minus 13 is 15 minus 13, which is 2. And my point there is 5, 2. So that satisfies, therefore it will also be in the perpendicular bisector. And then for S, 3 times 6 minus 13 is actually 18 minus 13, which is 5. And the point I was given there was 6, 5. So P, R, and S lie on the perpendicular bisector. So this is one of the ways in which you could do a question. The alternative would be that for you to notice that if I have those 2 points, and that's their perpendicular bisector, right? So that's point A and point B. For any point that lies on this perpendicular bisector, let me get an arbitrary point and call it K, right? So for any point that lies on the perpendicular bisector, KA is equal to KB, right? So if I can show that for the points PR and S, the distance PA is equal to PB, then that means those points must lie on the perpendicular bisector of AB. So I'm just going to do it for one of the points, but then you could also show it for the other points. Of course, for point Q, it will fail, and therefore what you'll actually have is that QA is not equal to QB. Therefore, Q doesn't lie on the perpendicular bisector. But we could check for PA. So the distance PA is going to be the uh, square root of 3 minus minus 1 squared plus negative 4 minus minus 6 squared, right? So that's going to be square root of 16 plus 4 squared plus 2 squared, which is square root of 20. Of course, you could write this as 2 root 5. That's okay. And now we check for PB. PB is going to be 3 minus 5 squared plus minus 4 minus minus 8 squared. This comes to the same thing, 2 squared plus 4 squared, which is root 20. So you can see that indeed PA is equal to PB, and therefore P lies on the perpendicular bisector of AB. Yeah, so this is also true for R and S. Are there any questions? Okay. if there are no questions, then I'll stop sharing so that the next presenter could come on board to share. So then we'll proceed to question 2. Where did the -7 come from? We're looking at a point that lies on the. We're looking at this point here. The -7 is the average of -6 and -8. Hope that makes sense. The midpoint, we're using the coordinates of the midpoint right here to find the equation of the perpendicular bisector, because the midpoint of AB lies on the perpendicular bisector. So that would actually be this point here. Does that make sense? Okay. All right. If there are no other questions, then I'll stop sharing. Then the next person could come on board.
Yeah, good morning, everyone. We shall go to question 2, which is still on coordinate geometry, the theme for our seminar today. And it reads, Tom is a landscape architect designing a new bike path for a local park. The path will connect 2 points. Point A, which is the entrance of the park, and point B, which is at the top of the hill. The coordinates of point A and B are 2, 4 and 8, 12, respectively. Tom needs to calculate the slope of the bike path to ensure it is not too steep for the riders. Then our task is to help Tom to determine the slope of the path and its midpoint. So this question wants us to get the gradient of the line joining those 2 points, A and B, and then the midpoint, which I think we can all do because we've applied these in number 1. Yeah, so we have 2 points, A and B, where A is 2, 4, and B is 8, 12. And our task is to get the gradient or the slope and then the midpoint. As we said in the previous question, gradient is got by taking the change in y out of the change in x. So for change in y, we shall have 12 minus 4. Then for a change in x, we shall have 8 out of 2. So this will give us 8 out of 6, which is actually 4 out of 3, or 1.3333 to 4 decimal places. Is our gradient. Yeah, then for the midpoint, which I can call capital M, we shall take the average of the x coordinates and y coordinates of A and B. So we shall have midpoint as 2 plus 8 out of 2 and 4 plus 12 out of 2. And this will be 8 plus 2 is 10, divided by 2 is 5. And 4 plus 12 is 16, divided by 2 is 8. So we shall have 5, 8 as our midpoint, and 1.3333 as the slope path. Yeah, that's what we had for question 2. I hope everyone is fine with that working. Any questions? Okay, I guess everyone is okay with that. Yeah, I'll stop sharing and invite the next discussant for question 3. Okay, let me display the solution briefly. So someone can take a screenshot, but we shall share these solutions in the group. That was the question, and that's the solution we have. Okay.
Okay, so this is question 3. I hope you can all hear me. It's a lengthy question. It's about Alice, a farmer in Bale district, who's planning to plant sorghum in parallel lines. The first proposed line is to pass through the earth coordinates 3050 and 1010, while the second line is to pass through the earth coordinates 2070 and 1050. However, she's not sure whether these lines are actually parallel to each other, and to ensure access to sunlight, a reasonable distance between the lines is needed. The minimum distance between them is 100 centimeters, but Alice does not know if the given coordinates do not meet this requirement. We've been asked to help Alice find the equation of the first and second lines and convince her that these lines are surely parallel to each other. Okay, so we have a line that goes through 3050 and 1010. You write this information here. So there's a line that goes through 3050 and 1010. And then there's another line that goes through 2070 and 1050. Now, getting the equations of these lines is not hard. So first thing you want to do is get the gradient. So I could call this line 1, and line 2. So I could let M1 be the gradient of the first line. This would be 50 minus 10 out of 30 minus 10. That's 40 over 20, which is 2. And I could also get M2 as well. This is going to be 70 minus 50 over 20 minus 10. Changing y divided by changing x. This is 20 over 10. This is also 2. The parallel lines have the same gradient. So already from this point, we know that the two lines are surely parallel. So because they have the same gradient, we are sure that they are parallel before we even get the equations of the lines. We can conclude since M1 is equal to M2, then then the lines are parallel. The lines are parallel. Now, okay, now to get the equations of the lines, we can use the equation that I had talked about earlier, y minus y naught out of x minus x naught is equal to m. So have y minus, we could use the point 10, 10 for the first line, y minus 10 out of x minus 10 is equal to 2. So this gives us y minus 10 is equal to 2x minus 20 when we multiply both sides by x minus 10. We could rearrange this and write it as 2x minus y minus 10 is equal to 0. I'm writing it in this form because for the next part of the question, we'll need to find distance between the lines. So this is for line 1. And then for line 2, we have that y minus, we could use the point 10, 50. So y minus 50 over x minus 10 is equal to 2. And so in this case, y minus 50 is equal to 2x minus 20. If we rearrange it and write it the way the previous line was written, it should be 2x minus y plus 30 is equal to 0. And this is the equation of line 2. So this is part A. This is part A done completely. You've been asked to show that the two lines are parallel. You have concluded that they are parallel because their gradients are equal. And we've also gone ahead to find their equations as the question had wanted. Yeah. Are there any questions up to this point? If there are none, then we can proceed to part B. Should Alice increase the distance between these lines? Because the question tells us that the minimum distance between them should be 100 centimeters. So we need to find out what the minimum distance between these lines is, and then see if it's enough, if it's at least 100 centimeters. And then if it isn't, then we'd have to make an adjustment to how far the y-intercept should be. Okay, so let's to find the minimum distance between two lines, two parallel lines, you'd get a point on one of the lines and find its distance from the other line, because that distance is uniform as the two lines progress. If you have two parallel lines, you realize that you could get this distance here. It should be the same. It should be the same at that point. Minimum distance between the two. It doesn't matter which point you pick. So if we have those two lines, and to get the minimum distance between them, we could pick a point on one of the lines. So we could choose to use line 1, right? And then pick a point on line 1. So we know that line 1 has a point 10, 10. So I could choose to pick a point on line 1, say 10, 10, and then find out how far 10, 10 is from the other line. 2x minus y plus 30 is equal to 0. This is just a sketch for the sake of answering the question. So it's not drawn to scale, but it's trying to illustrate what we're talking about. So the formula for minimum distance, the minimum distance of a point from a line is ax naught plus by naught plus c over the square root of a squared plus b squared. You take the absolute value of this just in case it's negative. And in this case, the equation of the line is ax plus by plus c is equal to 0. And then the point in question is x naught, y naught. So this is the formula that we use for minimum distance of a point from a line. So in this case, the minimum distance of 10, 10 from the line 2x minus y plus 30 is equal to 0. would be, in this case, our A is 2, so that's going to be 2 times 10 minus 10, because our B is -1, and our Y naught is 10, plus C. Our C is 30 in this case, and we're dividing all this by the square root of 2 squared plus -1 squared. So you realize that in the numerator you have 40, and then in the denominator you have root 5. So this is the actual minimum distance uh, between the two lines. Now, if you want, you can confirm this with another point. You could actually take a point from the other line uh, and then get its distance from the lower line. 2x minus y minus 10 is equal to 0. So you could take maybe 1050 or 2070 and find its distance from line 1. You realize that you add the answer you get to also be 40 over root 5. But the thing is, particularly for parallel lines, you realize that they have the same A and B values. And so the numerator, um, the numerator the numerator is actually always going to be C1 minus C2 divided by the square root of A squared plus B squared. This is how this is what we've found to be true. You could show this, but I request that we take it as is because it's a known thing. But you could show this if you want to, that the numerator is always going to actually be the difference between the C's. So I'm using C1 to mean the constant term on the left-hand side of the equation. So for line 1, C1 would be -10. And then for line 2, the C, so C2 would be +30. And so you see that that's actually consistent with what we've got. It's similar to what you have when you're looking at parallel planes, and you know that for the distance between parallel planes, you just get d1 minus d2. So yeah, it's a similar thing for parallel lines, that you'd just get the distance between the intercepts and divide it by the square root of a squared plus b squared. Yeah, so 40 over root 5 is certainly less than 100, and therefore this is not enough. According to the question that we've been given, it's not enough. So Ali should increase the distance between these lines. And the question is, how far must the y-intercept be for it to achieve the minimum, to achieve the required 100 centimeters distance? So we have said that the distance between those lines is actually going to be this divided by the square root of a squared plus b squared. But in our particular case, the distance between the intercepts, we can leave it as this because this is what we want to find. Our A is 2 and our B is -1. And so we saw that this will actually give us root 5. If we need this to be equal to 100, then that means the absolute value of C1 minus C2 will have to be equal to 100 root 5, 100 root 5 centimeters. So this would be the minimum distance for this would be the minimum distance for the y-intercept, for us to have at least 100 centimeters being the minimum distance between the two lines. So that's how we would do part B. I hope that makes sense. Are there any questions? The last part. Yeah, the constants. All right, I'm trying to see if I can illustrate it. So just give me just give me a minute or two. Yeah, so I'll just go through that again. So I was saying this is the formula for minimum distance. We know that this is the formula for parallel lines. And this can be derived, but it would need you to sort of use the derivation again of the formula for minimum distance. But you can see that there's a relationship here between the distance between the intercepts and the minimum distance between the two lines in that right angle triangle. And so we can use this formula to determine that the distance between the lines as they are right now is actually already 40 over root 5, but this is less than 100 and we want it to be equal to 100 at least. And so we can just use that because we know that the denominator is already root 5. We can just use that, put it to 100 and determine what the minimum distance between the intercepts should be. I hope this answers your question. Yeah. I'll try to draw up a proof for the entire derivation of this so that for those who would want to be satisfied, but otherwise I think we should proceed to the next question.
All right. Good morning. I hope everyone can hear me. We're going to look at question number 4. Oh, no. Okay, question number 4. Question number 4 reads, Engineer Paul is there to do construction on a rectangular plot of land. He hired a surveyor to determine the vertex coordinates of the available land, PQRS, and the coordinates were P17Q75R62 S04. So our task is to determine whether these coordinates are vertices of a rectangle, and then find the area of the plot of land. Yeah. So this is the plot of land, PQRS, and our task is to determine whether the coordinates are vertices of a rectangle. So what do you know about a rectangle? You know that a rectangle, the opposite sides are equal. The opposite sides are parallel. Yeah. So the solution, what I first started with, what we can first start with, is to find the slopes of all the sides given to us, of PQ, of QR, of RS, of SP. So when we calculated the gradient of PQ, we got 5 minus 7 out of 7 minus 1, which gave us negative 1 out of 3. And then the gradient of QR, 2 minus 5, 6 out of 6 minus 7, which gave us the answer as 3. And then for the gradient of RS gave us negative a third, and the gradient of SP gave us 3. So on evaluating, we realized that the gradient of PQ times the gradient of QR gives us negative 1, which means that PQ is perpendicular to QR. So there's a right angle at Q. Same case as for RS and SP. Multiplying their gradients gave us negative 1. So that means also that the RS is perpendicular to SP. I hope we're all at par. Then we went ahead to calculate the length of the sides, yeah, PQ and QR. So PQ gave us 2 root 10, 7 minus 1 squared, 5 minus 7 squared, all under square root. I hope you know how to use that formula for length of slides. Then the length of QR gave us root 10, yes? So now that we found out that PQ is parallel to QR, and on realizing that before that, we also realized that the gradients of PQ and RS were similar, and the gradients of QR and SP were also similar, which means that those lines are parallel. Yes. So yes. So that means that since PQ is perpendicular to QR and RS is perpendicular to SP, and PQ parallel to RS and PS parallel to QR, and the length of the opposite side is not equal, then the shape is a rectangle. Do you all agree? I hope so. Then we went, they asked us first, from what we've calculated, let's find the area of the plot of land. So since our length was PQ, our length PQ was 2 root 10, and our width QR was root 10, the area is length times width, which is 2 root 10 times root 10, which gives us 2 times 20, and the answer is 20 square units. Yes, that's the area of plot of land. And that's not the only way to calculate and prove that the coordinates of the vertices of the coordinates are vertices of a rectangle. You can also use the concept of midpoints and diagonals. Yes. So if you calculate, and for the diagonals have the same midpoint, the diagonals are PR and QS. Yes. When you calculate, you'll get 7, 2, and as well as 9, 2 as a coordinate, yes, of the midpoint. And then the length also of the midpoint, you also calculate it and you'll find it as root 50, which is the same length. So you can use either the first formula or the formula for the concept of diagonals and midpoints, because they all prove that the shape is a rectangle. And then you calculate and find the area of the plot of land. So are we all at par? Any questions? Okay, let's see. Okay, someone is asking, can I share more light on the second formula, especially the oh, I was too fast. I'm really sorry. Um, okay, so do I start over? Do I repeat the whole explanation? Okay, let me just um repeat the whole question. Okay. Um, wait. Okay, repeating the whole question, it is. Okay, so question number 4. Engineer Paul desired to do construction on a rectangular plot of land. Yes. He hired a surveyor to determine the vertex coordinates of the available land, PQRS. Yes. And the coordinates were P17Q75R62S04. So what we want to determine, the task is to determine whether these coordinates are vertices of a rectangle and thus find the area of the plot of land. So what do you know about a rectangle? For the person who was asking about the concepts of diagonals and midpoints, we know that, okay, let me first go to the formula I shared. Hope you can all see my screen. My screen. Okay, can all see my screen. Okay. Oops, excuse me. So that's our plot of land, yes. So I first went ahead to calculate the slope of this PQ, of the line PQ, the slope of RS here, the slope of QR, the slope of PS, yes, i.e. the gradients of all the lines, yeah, because before we even approach the question, we want to assume that we don't know if it's a rectangle or not, yes. So I went ahead to calculate the slopes of all the different lines, PQRS. Yes. So on calculating the slope of this line PQ, we got -1 out of 3. Yes. On calculating the slope of RS down here, we got -1 out of 3. That means that if the slopes of the two opposite lines are equal, that means the lines are parallel. Yeah. So then for PS and Q, we got the slope of PS, SP, which gave us 3, and the slope of QR, which was also 3. Yes. So these two slopes, the gradients of these opposite lines were equal, and which was 3. That means that they are parallel. Yeah. So and then yes. So also realizing from the slope of PQ, -1 out of 3. Yes. And the slope of QR, which was 3. Multiplying these two gradients gives us -1. Yes, so that means that PQ and QR are perpendicular. Yes, hope you all agree. Hope you're all at par. Then the same thing as RS and SP. Yes, on calculating multiplying the slope of RS and SP, we got -1. -1 out of 3 times 3 gives us -1. So RS and SP are perpendicular. Yes. Yes. Then I went ahead and calculated the length of the sides, EQ and QR, to show that they are not equal, because we know that because if we just stop there at the step before, that means that could be any quadrilateral, could be a square actually, because even squares have the same concept of the opposite sides are parallel and perpendicular also. So I went ahead and calculated the length of the slides. If the length PQ gave us 2 root 10 and the length QR gave us root 10, yes? And so then the area, which was 2 root 10 times root 10, which gave us 20 square units, yes? Let me see if there are any questions. Wait. If any questions. Okay, let me go ahead and explain the concept of diagonals. So the person was asking for the concept of diagonals. So in this question, we have given diagonals PR and QS. Yes, we are given the diagonals PR and QS. So for a rectangle, both diagonals have the same midpoint, yeah? And both diagonals also have the same length. So because if we have that, that means that the shape is a rectangle. So in calculating the diagonals PR and QS, we're calculating the midpoint. The midpoints were the same for PR and QS. For PR gave us 7 out of 2 and 9 out of 2. In calculating 1 plus 6 out of 2, 7 plus 2 out of 2. You can calculate that in your book, yes? And then same concept as the midpoint of QS. The midpoint of QS also gave us 7 out of 2 and 9 out of 2. What does this tell us? So both diagonals meet at the same midpoint. That means that the diagonals bisect each other, yes? So the shape is a parallelogram. For now, it's a parallelogram because for a parallelogram, the diagonals bisect each other. Then if you go further ahead and calculate the length, yes? The length PR and QS. When calculating the length of PR and QS, we have the same length, which gave us root 50, if you calculate in your book right now at notebook of yours. So PR and QS were the same, the diagonals were equal. So now we know that the diagonals bisect each other and the diagonals are equal. So this means that the shape is a rectangle. Yes. So are we all at par? John Victor gave a thumbs up. So that means that someone is at par. Anyone else? Okay. Yeah, success in your exams. Thank you.
So, good morning, everyone. I hope you can hear me and see my screen as well. Like, can you? Okay. Yeah, so we are looking at problem 5 right now, and it says, what's the equation of the straight line joining the points? Okay. Yeah, a straight line joining points A, which is 7, 0, and B, 0, 2. Yeah, so we are required to obtain the equation of the straight line AC, some other line, such that the x-axis bisects the angle BAC. So we are going to start with finding the equation for line AB. So the points we have are A 70 and B 02. So we start by finding the gradient using this formula here. So we have 2 minus 0, 0 minus 7. So we have negative 2 out of 7 as our gradient for line AB. So using that point, we are going to find the equation of the line. So we have, okay, this is from this very formula. This whole thing comes from here. So we have our we are using this point here, 7, 0. So we have y minus 0 and then x minus 7. And our gradient here, which is negative 2 out of 7. And this gives us the formula for that line. Yeah. So we can also use this because we already know that the point B02 is the y-intercept. So from this, is it general equation or something? Yeah, we know our value for C is going to be 2 already. Yeah, so we have something looking like this. Then we can use 0.70 to calculate the gradient here, and then just fill out the gradient within this equation here, and we are done. So do we all get it till this point? Okay. I'm going to assume everyone does. And we are going to the next point, which is finding the equation of some line here, of line AC. Now they told us that AC, let me first go back to that slide so that we see. So they said obtain the equation of a straight line AC such that the x-axis bisects the angle BAC. Right? So we have, yeah. So I drew something here to visualize everything. So this is our line AB, something like this. And then AC is going to be some line like this. So it must pass through A, and the angle between BA and AC must be bisected by the x-axis here, yeah? So this is alpha, right? Yeah. This is alpha. So this angle here is equal to this angle here. Right? Now, SC is going to be like some random point on this line. We don't know its value for sure, but we have to find the equation, okay? But now that we know that this angle here is equal to this angle here, we can conclude that the line SC is a reflection of the line AB. Yeah? About the x-axis here. So that means we can find the reflection of point B, yeah, about the x-axis is going to be we are calling it B prime. Yeah, it's right there. So knowing that we have 2 points on this line, B prime and A prime. Yeah, so we can use those 2 points to find the equation of our line. Okay, so let's see. So we said we have agreed that the reflection of the line AB about the x-axis is the line AC. Okay, what this implies is that, okay, there is this is a fact that if a line is reflected across the x-axis, yeah, then the gradient of its reflection is going to be the negative of its gradient. Okay, I hope the words make sense, but this is the statement here, yeah, because the gradient of AB was negative 2 out of 7. It means that the gradient of AC is going to be 2 out of 7. Okay, so from that we have its gradient, and we know that the reflection of B about the x-axis is B prime here, and that point is 0, negative 2. Okay, so we have a point on the line, and this is the y-intercept anyway. So we don't really have to do any calculations. We have the gradient and the y-intercept. Or instead of in case you do not know the fact that the gradient is going to be negative, if you do not know this fact, you can still calculate the gradient. So you can since we said we know the points A and B prime lie on the line AC, we can use those 2 points. So A was 7, 0, and B prime is 0, negative 2. So using this equation, we find that our gradient is 2, 7, and then yeah, we can like just conclude this because we know that this point is the y-intercept. Any questions? Um, okay, so I guess the next person can. Oh, all right. Let me share. Okay. Okay. So I'm reflecting because the question said, let me go back. Right. Okay. Here the question says that the x-axis bisects the angle BAC. Okay. So yeah, so look at this diagram, yeah? This is B, this is A, and this is C, okay? So I've drawn, well, some random, this line AB, and then some line AC, yeah? So A is like a common point. And they told us that this axis here, the x-axis, is bisecting this angle, right? So this angle, this side is equal to this side. What this implies, when you bisect something, like if what does that mean? Okay, if this angle here is equal to this angle here, yeah, that just implies that this is reflected across here because this point, we have some points on this line here that is going to correspond exactly to this point here. And if we look at point B, if you look at the distance from point B to point to like the center 0 0, yeah, 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 it's exactly the same. It should be exactly the same distance from here to here because this angle is equal. Think of it as a triangle, okay? If you have a triangle and you have a bisector here, an angle bisector up here, right? This is going to be like 90 degrees, 90 degrees, and yeah, this side is equal to this side. All those things. I don't know. I don't know. Does it make sense? Should I? Yeah, so it does make sense. All right. Okay. Okay, I guess I'll leave this to the next person.
Yeah, without wasting any time, question 6, right away. A line is drawn to the point P, 2, 3, making an angle of 45 degrees with the positive direction of x-axis, and it meets the line x is equal to 6 at Q. So we've been asked to find the distance of Q from the origin and the equation of the line through Q perpendicular to OQ. Okay, so if we would have a little sketch of all this, sorry, we'll have a little sketch of all this, with that being the x-axis and the y-axis. The line that's initially talked about, which goes through the point P, would be somewhere there. Okay, that would be our point P, for example. And then our point Q could be somewhere there, perhaps. And yeah, the angle right here is 45 degrees. And the x-coordinate here is 6. This is 2, 3. And we've been asked to find out the distance of Q from the origin. So we want to find out that length right there, and then the equation of the line perpendicular to OQ. So we're going to have another line going through Q, but perpendicular to OQ. Yeah, so something like that. And that's the line whose equation we want. Okay, so first of all, we would need the y coordinate of point Q. That means we need the equation of the first line that has been talked about. And we have a point on that line 2, 3, and the angle it makes with the positive direction of the x-axis. We know that the tan of that angle would actually give us the gradient of that line. And tan of 45 is 1, so m is equal to 1. And so it shouldn't be hard for you to see that you can get the equation of this line easily. Y minus 3 out of x minus 2 is equal to 1. If we use y minus y naught over x minus x is equal to m. And this, when you simplify it, should give you y is equal to x plus 1. Now, if this is true, that means the y coordinate of point Q, right? So therefore, when x is 6, y is equal to 6 plus 1, which is 7. Yeah, so when they say it meets the line x is equal to 6, you might want to draw another line and be like, oh, let me solve this equation simultaneously. Well, yeah, but the line x is equal to 6 is just a straight vertical line along which x is 6 throughout the line. So we know that along that line x is going to be 6, and so that would simply be the point Q is simply basically when x is 6 along the line. So along the line that along the line y is equal to x plus 1. So we can easily get its y coordinate by just substituting in the equation. And so the y coordinate of point Q is 7. So Q is at 6, 7. Yeah, so we have found point Q. The question asks us to find the distance of Q from the origin. So if we want OQ, this is simply going to be the square root of 6 minus 0 squared plus 7 minus 0 squared. So that's 36 plus 49, square root of 85. That is the distance OQ, so distance of Q from the origin. And the equation of the line through Q perpendicular to OQ, we would need to find the gradient of OQ first. So the gradient of OQ is 7 minus 0 over 6 minus 0, which is 7 over 6. Therefore, the gradient of the line perpendicular to OQ is going to be the negative reciprocal, so negative 6 out of 7. So basically negative 1 divided by 7 over 6, so negative 6 over 7. So again, we can use y minus y naught out of x minus x naught to give us the equation of this line. So if we do that, this simplifies 7y minus 49 is equal to minus 6x plus 36. So 6x plus 7y is equal to 85. You could leave it like this. You could decide to make y the subject. You could bring the 85 to the left. Doesn't matter really, but that would be your final answer. Any questions? Okay, it seems that question was pretty smooth. So if there are no questions, then I'm going to stop sharing and hand over to the next presenter to do question 7.
Um, yeah, makes more sense. Okay, so we are going to look at problem 7. I hope you can hear me and see my screen as well. Okay, so the question said, find the equation of the line parallel to the equation of the line x plus 4y is equal to 1, and which passes through the point of intersection of the lines y is equal to 2x, and x plus y is equal to 3. Okay? So we are going to start by finding this point of intersection between these two lines here. Yeah, such that we have a point where this line we want to find passes. So the lines we have are y is equal to 2x and x plus y is equal to 3. So we substitute y is equal to 2x into this equation, and then we have that x is equal to 1. Yeah, then from that, we can conclude that y is equal to 2. Yeah, so we have that point of intersection as 1, 2. Yeah. Then, so to find, let me go back to the question a bit. So they also said, since these lines here are parallel, it means the gradient of this line is going to be the same as the gradient of this line we want to find. Okay, so we are just going to manipulate this to look like, that form where you have m, the gradient somewhere, such that we know the gradient of this line we want to find. Yeah, so here goes. So you have, this is the equation we're given for the line. So we have 4y, like, when you take this x on the other side, so you have 4y is equal to the negative x plus 1. And then we divide by 4, and we have negative 1 out of 4 plus 1 out of 4, x, all that. So this, the coefficient of x is our gradient. So we have m is equal to negative 1 out of 4. So from there, we find the equation of the line. So we know that it's parallel to this, so that its slope is going to be the same as the other one's slope, which is negative a quarter. And then it passes through the other points of intersection, which is 1, 2. So for using this and this, we use that general formula. So we have y minus 2 and x minus 1 is equal to negative a quarter. Then, manipulate it. And then you have y is equal to this, negative a quarter x plus 9 out of 4. Yeah, and then you have 4y. Okay, you can just put it the way you want, but when you reach this point, you're pretty much done. And you can write it this way or that way. Yeah, that's it. I hope everyone understands. If there are any questions. Okay. Right. Oh, point of intersection. Okay, let me get back to that. Yeah, so the point of intersection Let me go back to the question. Yeah. They said this line here passes through the point of intersection of these lines, okay? So point of intersection means where these two lines meet. Like let me try drawing so that to visualize it. Yeah, it means something like, so intersection is this point here, like where they are meeting, yeah? I hope that makes sense. So they are saying this line we want to find passes through that point. Let me change a color. Yeah, so this line here, whose equation we want to find, passes through this point here. Yeah, and it's also parallel to some other line with that equation, let me see, x plus y. Okay, it's so hard to write like this, but like I hope you get the point. Okay. Okay, I hope that makes sense, but like you get that point. So we are trying to find the equation of this line. There's a pointer. We're trying to find the equation of this line here. It passes through this intersection of these two lines, y is equal to x and x is equal to 3. And then it's parallel to this line here. Is that, do you get that?
No.
No. Right. Okay, do you not understand what intersection means, or do you not understand how we get the point of intersection?
How the point of intersection helps us to get the gradient, the equation of the line.
Oh, okay. Yeah, so here's the thing. To get the equation of the line, yeah, we need to either have 2 points, yeah. That helps us find the gradient, then after we use one of the points to find the equation of the line. But in this case, we can find the gradient of the line from this line is parallel to, yes. And then we need to find one of the points through which this line passes. And we know that this line passes through the point of intersection. So from there, this first part here is showing us how to find this intersection point, yeah? This is the point of intersection. And the question says, this line here passes through this point of intersection, okay? So when we have this point and we have found the gradient from here, we use those two conditions or those two facts to find the equation of the line. So we use that where we use some random point x, y, and we use the point 2, sorry. Yeah, the point of intersection, this one, and then the gradient to find the equation of the line. So you have y minus 2 and then x minus 1 being equal to negative a quarter. And then you manipulate this whole thing and then to give you the equation of the line, which is this one, or this, depending on how you want to write it. Do you get it now? All right.
Yeah. Um, We shall go to the next question, which is question 8. I hope you can all hear me. You can hear me perfectly. Yeah. So question 8. So the point A, 1, 5 is drawn a line parallel to the x and the sign of the angle to PQ is to the point A. 1, 5 is drawn a line parallel to the x-axis. Can try to
Okay, Brian seems to be having network issues, so I'll step in and do the question. I'll start. Yeah, we can be so that we don't lose out. So the point A 1, 5 is a drawn line parallel to the x-axis through the point. A line is drawn parallel to the x-axis to meet at B the line PQ, whose equation is 3y minus 2x is equal to -5. Find the length of AB and the sine of the angle between the line PQ and line AB, hence show that the length of the perpendicular from A to PQ is 18 over root 13. Okay, so there's a lot going on in this question. So we want to break it down slowly so that we're able to actually solve it. Sketches always help. Let me just erase that. Draw a straighter line. So we have something like this. The point 1, 5 is to be around there, and through that line, a line parallel to the x-axis is drawn, and it meets the line PQ, whose equation is 3y minus 2x is equal to 5. So this is the line 3y is equal to 2x minus 5. That's a positive gradient line. Its intercept is negative though, so it's going to look something like this. Yes, that's the line PQ. Line PQ. And so the point B should be somewhere there. That's our point A. So that's AB and line PQ. And moving us to find the length of AB and the sine of the angle between the line PQ and line AB. So to find the sine of that angle, you know, sine of an angle is opposite out of hypotenuse. So we would need that point there and this point here to give us the length of the opposite, and then divide it by the length of the hypotenuse, which would be this point. We could call it point, let's call it point N. So we could find NB, and if we call this point F. So Fn divide by NB. Yeah, I think we could do that. to find the sine of the angle. Okay. Just check the chart. Okay. So step one, let's find the coordinates of point B. So the line, this line which is parallel to the x-axis means its gradient is 0, okay? The line is parallel to the x-axis, that means its gradient is 0, so the equation is usually just of the form y is equal to the y coordinate that any of the points on that line goes through. So because this goes to the point 1, 5, and it's parallel to the x-axis, in other words, its gradient is 0, so y is equal to 0x plus 5, y is equal to 5. So we have the line y is equal to 5, and so that means the y coordinate of point B, the y coordinate of point B is 5. So the x coordinate would be whatever we get when we substitute for y in that equation. So if I did 3 times 5 minus 2x is equal to negative 5. 15 minus 2x is equal to minus 5. So 2x is equal to 2x equals 20, x equal to 10, right? So B, the coordinates of B are 10, 10, 5. Just want to confirm that that indeed satisfies the equation of the line, both lines, and indeed it does. So B is at 10, 5. So to find the length of AB, that's pretty simple. Because this is on a straight horizontal line, A is at 1, 5, B is at 10, 5. So AB is simply going to be, okay, let's use the formula. 10 minus 1 squared plus 5 minus 5 squared. So it's just square root of 9 squared, which is 9. So AB is simply 9 units. Are we together so far? Any questions along the way, please feel free to raise your hand, okay? So AB is 9 units. Now we want to find the sine of the angle between the line PQ and the line AB. So okay, there are two angles, and there are a number of ways you could do this. If you have a little knowledge on vectors, you might decide to employ a little bit of your knowledge on vectors to do this, because you know that to get the angle between two lines, you can use the dot product. But we're not going to do that. We're just going to simply use the lengths. We're going to use the length. So this point F, we know that point F is going to be 0, 5. Because that's the line y is equal to 5, and that's point F we have a 0. So we need to find the coordinates of point N. Point N is when x is 0. So when x is 0, if you substitute in that equation, you should get negative 5 over 3. So this should be 0, negative 5 over 3, just by looking at the equation of the line. So the sine of that angle, again, we are assuming that it's going to be the acute angle and not the other angle. But the sine of theta would be Fn divided by Bn, right? Now what's Fn? Fn is simply going to be, okay, I'll use the formula 0 minus 0 squared plus 5 minus 5 over 3 squared. And then Bn is going to be 10 minus 0 squared plus 5 minus 5 over 3 squared. So in the numerator, we have 5 plus 5 over 3, which is 15 over 3 plus 5 over 3. So that's going to be 20 over 3. And then in the denominator, we have the square root of 100 plus 400 over 9, because we have 20 over 3 squared, which is 400 over 9. So let me write that, 100 plus 400 over 9. That's 1300 over 9. You could just help me confirm all of this is true. 20 over 3 divided by the square root of 1300 over 9. You'd like to know why we used sine? The question asks for the sine of the angle. Sorry. The question asks for the sine of the angle, so that's why we are doing that. I hope that makes sense. Yeah. So, and we know that sine is opposite over hypotenuse. You can clearly see that this is a right angle triangle, and the opposite of the angle theta is Fn, and its hypotenuse is Bn. Yeah, so this would be your answer. This actually simplifies to 20 over the root of 1300, which is 20 over, so this is actually 2 over root 13 when you simplify that. Yeah, so if you go ahead and like divide by a number of things, then eventually you get that. So that would be the sine of the angle, 2 over root 13. And we want to show that the length of the perpendicular from A to PQ is 18 over root 13 as well. So I hope where we are right now, we are like together. Okay, let's have a look. We want to show that the perpendicular from A to, we drop a perpendicular from this to this point. The length of that perpendicular should be 18 over root 13. Let's call that point R. So one show that AR is 18 over root 13. So an easy way to do this is to find the coordinates of point R, right? We already established that this is 10. So we find the coordinates of point R. R lies on the line PQ, but then AR is also perpendicular to PQ. Okay, so AR is the minimum distance of the point A from the line PQ. So we could use the formula for minimum distance. Yeah, so the length AR is actually the minimum distance of A from PQ. Coordinates of A are negative, positive 1, 5. Sorry. 1, 5, and then the line PQ, its equation is 3y minus 2x equal to negative 5. 3y minus 2x is equal to negative 5. So we could rewrite this as 2x minus 3y. 2x minus 3y minus 5 is equal to 0. So we have this as our point and this as the equation of the line. If we use the formula for minimum distance, this is going to be absolute value of 2 times 1 minus 3 times 5 minus 5 out of the square root of 2 squared plus minus 3 squared. So what do you have when you calculate? You'll have 2 minus 15 minus 5, which is minus 18, but Yeah, 18 over root 13. Which is what they wanted us to show, right? Yeah, so that's how we would do that question. Any questions? Okay, I hope that was clear. Like I said, there's more than one way to get a sign. If you want, you could investigate using a dot product. If you want for AR, you could also investigate finding the coordinates of point R and then using the formula of distance between 2 points to find the length of the perpendicular from A to PQ. You could use vectors for actually many coordinate geometry questions. So be open-minded in that sense. That brings us to question 9, which is the final question for the seminar. A link has been shared in the chat for feedback, so please attend to that. Please leave your feedback for the seminar. It helps us improve on how we work. But also, if you're not in the MathUp S6 2026 group, you're encouraged to join so that it's for your own good. Yeah, it's for your own good. There's question breakdown in the group, and you can always send any question that gives you a hard time, and it will be attended to. And that's also where we coordinate our different activities like the seminars. Yeah, we also have tutoring services. There'll be a flyer that's shared in the chat. So if you like what you see and you're interested in being tutored, you can always reach out to us as well. And the recording for the seminar will be shared on our YouTube channel, and there are some other videos there that you could check out of previous seminars and also different topics as well. So yeah, feel free to be part of the MathUp community. Not just today, but going forward as well, especially as you prepare for your final year in high school. Yeah, so that brings us to question 9. The solutions will be shared in the group as well, so you don't have to worry about that. And we've been asked to find the equation of the angle bisector of these two lines. Now, there are various ways to do any math question, right? But we always want to look for a way that doesn't make you work too hard. So you could sketch the lines so that you sort of have an idea of what we're looking at. We have two lines. 4x minus 3y plus 1 is equal to 0. So that line has an intercept at we could write it down. So 4x minus 3y plus 1 is equal to 0. It's the same as 3y is equal to 4x plus 1. Y is equal to 4 over 3x plus 1 over 3. So this line goes through 0, 1 over 3, and its gradient is 4 over 3. So something like that. And then you have the line 3x minus 4y plus 3 is equal to 0. So this is 4y is equal to 3x plus 3. Y is equal to 3 over 4x plus 3 over 4. So this line has a smaller gradient, but a higher intercept. So it would look something like that. Yeah, not drawn to scale again, but this is what the two lines look like. Now, we're being asked to find the equation of the bisector of the angle between the two lines. Now, always note that when two lines intersect, there are two angles that are formed, two pairs of angles, actually, I should say. And so an angle bisector isn't specific. We would need to have the angle bisector for the acute angle between them, right? But we could also get the angle bisector for the obtuse angle between the two lines. Okay, so there's more than one angle between the two lines, and therefore there's more than one angle bisector for the two lines. Now, you could do this question using trigonometry. So that means you're going to sort of relate the gradients of the lines. Relate the gradients of the lines to the angles that the lines make with each other. And then from there, you're going to think about how you can manipulate those to get the equation of the angle bisector. But we could also use the fact that, and that's the first thing that we're going to do, the fact that for any point that lies on the angle bisector, let's have an arbitrary point, P, X, Y. Its distance, its minimum distance from this line is exactly the same as its minimum distance from the other line. So that's a property of points that lie on the angle bisector. And so we're going to use that to determine the equations of the angle bisectors. But we're also going to look at the other method since we have some time on our hands, and this is the last question. Okay. So I have a question here about how you get to know the nature of the lines on the Cartesian plane. When you write your equations in the form y is equal to mx plus c, m is the gradient of the line and c is the y-intercept. So y-intercept is basically where the line touches the y-axis, and the gradient is basically how steep or how much it's slanting, basically. So now if it's a positive gradient, that means it's going to increase as it moves to the right. The line is going to increase as it moves to the right. So both of these are positive. So there's an increase as we move to the right. However, one is more positive than the other. So the one with 4/3 is steeper than the one with 3/4. And then, yeah, for the intercepts, again, we can see that this line, 4x minus 3y plus 1 is equal to 0, has an intercept at a third. And the other line has its y-intercept at 3/4. So that's why the lines look like this. It's important to know how to sketch lines because it gives you a better insight as you approach the question. If you just draw random lines and your sketch isn't, like mine isn't to scale, but it's accurate, if that makes sense. In the sense that if I were to actually sketch the lines to scale, then it would look something like this. So it preserves the general appearance of what it would actually look like. I haven't just drawn two random lines. I could have said, oh, one line is like this, the other line is like this, but no, they're not perpendicular. So this would be a bad sketch to use. So this is the appropriate sketch that we should be using. So if we use the fact that all points that lie on the perpendicular bisectors of these lines, sorry, on the angle bisectors, points that lie on the angle bisectors are equidistant from both lines. In other words, the minimum distance of points on the angle bisectors from both of the lines are the same. So in other words, if I use the formula for the distance of P from the line 4x minus 3y plus 1 is equal to 0, it should be equal to the distance of P from 3x minus 4y plus 3 is equal to is equal to 0. Now remember, our formula for minimum distance of a line is ax plus by, ax naught plus by naught plus c over the square root of a squared plus b squared. So if I do that, I'm going to be saying that 4x minus 3y plus 1 divided by the square root of 4 squared plus negative 3 squared is equal to the absolute value of 3x minus 4y plus 3 divided by the square root of 3 squared plus minus 4 squared. It's important that you have the absolute value signs as you approach this question, because that's how the formula is. If you do this without the absolute value signs, then you're only going to get one of the angle bisectors and you won't get the other one. So to get the two angle bisectors, we are going to equate, of course, when you simplify, you realize that the denominator is the same, right? And the denominator is 5, so we can do without it. And so we just have 4x minus 3y plus 1 being equal to 3x minus 4y plus 3. Now, when you have this, you could have your case 1, where 4x minus 3y plus 1 is equal to the positive of this, which is 3x minus 4y plus 3. When you simplify this, if you bring the x's and y's to the left, you'll have x plus y being equal to 2. So this would be your equation with a line. If you want, you can write it as y is equal to minus x plus 2. If you look at our sketch, that line must actually be this line right here. So y is equal to minus x plus 2, because it has a negative slope. So that must be the line that we are talking about. And so that would be the equation of one of the angle bisectors. However, we want to have the equation of both. So what do? We consider the second case, case 2, and that would be when 4x minus 3y plus 1 is equal to the negative of this. So that's going to be minus 3x plus 4y minus 3. So taking the negative of this, we can always keep the left-hand side positive and then vary the sign of the right-hand side. So we can do when the right-hand side is positive and when the right-hand side is negative. If we make them 4 cases, then the other 2 cases will just be repetitions of these 2. If we decide to make the left-hand side negative, because if they are both negative, it's the same as them both being positive. And then if one of them is positive and the other is negative, it will just be the same as this case 2 that we're doing right now. So when you simplify case 2, then you get 7x minus 7y. If I bring the minus 3 here, then plus 4 is equal to 0. And I realize this is the line 7y is equal to 7x plus 4. If you were to divide by 7, that would be y is equal to x plus 4 over 7. And now that must be this line right here. So y is equal to x plus 4 over 7. So that would be that angle bisector. So this is a simple, okay, I think a straightforward way to get the angle bisectors using the fact that any point on the angle bisector is actually the same distance from both of the lines if we're considering the minimum distance. And so you're able to get the two angle bisectors using the formula for minimum distance of a point from a line. Does that make sense? Are there any questions there? Okay. The reason we made one negative in case 2 was because if you have an equation, right? Let's say the absolute value of alpha is equal to the absolute value of beta, right? There are two cases when this could be true, right? Because let me just illustrate. So the absolute value of 3 is the same as absolute value of 3, but the absolute value of 3 is also the same as absolute value of -3. So you're not sure whether it's actually the same number or it's just the negative of the number. So that's why we use the negative as well. That's why we take the two cases, because you're not sure, because we're just taking the absolute value. But if we want the real number itself, I'm not sure whether it's positive or negative. So we have to do both cases. And indeed, both the cases give us the actual bisector. I hope that answers your question. Okay, so now if we're to look at the trig method, it's pretty long. But I'm just going to sort of try to touch it a little bit. Okay, so I've been asked to repeat criteria for which we are able to draw accurate sketches. You really just want to write the equation of your line in the form y is equal to mx plus c, right? So you want to write it like this. And then m will give you the gradient of the line. The gradient of the line is basically how it's going to be slanting. Will it be like this? Will it be like this? Will it be like this? So if it's a zero gradient, it's going to be a straight line. If it's a positive gradient, you expect it to be like this. Now, depending on how positive, if it's a high positive number, then it's going to be, steep. But if it's a small positive number, like a fraction, especially a fraction less than 1, then it's going to be like that. So if it's negative, again, a small negative fraction would be like that. A large negative number would be like that. So negative sloping, which means as you proceed to the right, it goes down. Yeah. The vertical line has a slope that's undefined, so we don't really talk about it. And then the C is basically where the line touches the y-axis. So if you have the M and the C, then you can always draw a semblance of the line. Yeah. I don't want to take more time on that. Let's proceed to looking at how the question will be done using trig. So you have to be careful doing this question using trig, because it comes with a lot of complications. So if I just repeat the sketches of the lines. Okay, that's not the line. The line doesn't go through the origin. Keep drawing the line through the origin. Okay, I think those are the lines now. So this was 4x minus 3y plus 1 is equal to 0. And then 3x minus 4y, 3x minus 4y plus 3 is equal to 0. So like I had said earlier, we have two perpendicular bisectors, right? So we have two angle bisectors. We have one right there, Then you have the other one right there. So, without further ado, let's get into the question. We know that after having written the lines in the form y is equal to mx plus c, we have that one line is y is equal to 4 over 3x plus a third. And the other line is y is equal to 3 over 4x plus 3 over 4. Now, we know that the gradient is equal to tan theta, right? For lines like this, the gradient is equal to tan theta, where theta is the line that the angle makes with the angle the line makes with the positive x-axis. Sorry, theta is the angle the line makes with the positive x-axis. So what would that mean? It would mean that the tan of, let's be careful with the angles, okay? It would mean that the tan of this angle here is 4 over 3, and then the tan of this other angle here is 3 over 4. So I'm going to call that angle theta 1. I'm going to call that angle there theta 2. So because here this tells me that M1 is 4 over 3, therefore tan of theta 1 is 4 over 3. And here M2 is 3 over 4, therefore tan of theta 2 is 3 over 4. I hope we're together at this point. So tan of theta 1 is 4 over 3, tan of theta 2 is 3 over 4. Now we want to find the tan of the angle between them. What's our strategy? Our strategy is, I could just maybe expand on the part that we are drawing. We know that if I can get the size of this angle, right? If I can get the size of that angle and then divide it by 2, right? Because a bisector splits the angle into 2 equal sections. I can divide it by 2 and then add it to the smaller angle or subtract it from the bigger angle, then I'll be able to get the gradient of the line, which is the angle bisector. And I know that that angle bisector goes through the intersection of the two lines. So I'll have a point on the line and the gradient of the line. Let me just repeat that, okay? Because if I get theta 1 minus, okay, the difference between those two lines is theta 1 minus theta 2. You don't see that, you can use the right angle triangle we have here. We have theta 1 there, and this is theta 2. So if you use the fact that the sum of two interior angles will give you an exterior angle, then that angle there, which we're looking for, is theta 1 minus theta 2. But if I get half of it, right, if I get half of it, and then I add that half to theta 2, then I'll be able to get this angle here, which would give me the gradient of the angle bisector. Yeah, so that's the motivation for us using trig. I think you can already see how lengthy it's going to be. But we have to get theta 1 minus theta 2. So theta 1 minus theta 2. To get theta 1 minus theta 2, which is this angle here, the angle between the two lines, we're going to use trig. So I'm going to use the tan of theta 1 minus theta 2 being the tan of theta 1 minus the tan of theta 2. If you haven't done trig yet, then you can look up these identities at the back of a logbook. Over tan theta 1 minus tan theta 2 over 1 plus tan theta 1 2. But tan theta 1 is 4 over 3, so it's going to be 4 over 3 minus the tan of theta 2. The tan of theta 2, which is 3 over 4. And then I'm dividing this by 1 plus the product of the 2, which is 4 over 3 times 3 over 4. Now, 4 over 3 minus 3 over 4 is 7 over 12. And then in the denominator, you have a 2. So that's going to be 7 over 24. So that's the tan of the angle. But now we want to get half the angle, right? So if tan of theta 1 minus theta 2 is 7 over 24, how do we get the tan of theta 1 minus theta 2 over 2? And what we're going to use is the T formula, or basically the expression for tan of 2x. Tan of 2x is 2 tan x out of 1 minus the tan of x squared. So this is the expression we're going to use. So I'm just going to let this be t, right? And then we can use the T formula. So if we do that, then we'll basically be saying that 2t is, 2t over 1 minus t squared is equal to 7 over 24. And then our task becomes to find t. Notice that we're going to get a quadratic equation. And because we're going to get a quadratic equation, we have to be careful about the roots that we get. One of them will be relevant to our question, and the other, we are not so sure whether it will. So if we simplify this, this is 48t is equal to 7 minus 7t squared. And so 7t squared plus 48t minus 7 is equal to 0. If we decide to factorize this, of course, you could solve it in any way you can. I see that factorization is a bit straightforward, so we can do that. 7t into t plus 7 minus t plus 7 is equal to 0. So 7t minus 1 into t plus 7 is equal to 0. So t is either equal to a 7th or t is equal to negative 7. But let's be careful, right? Because if t is equal to, the reason why we have two angles here is because, again, even for trig, if the tan of theta 1 minus theta 2 is 7 over 24, there are two possible angles for which that could occur. Remember, tan is positive in the first quadrant and in the third quadrant. Now, if you get an angle in the third quadrant and divide it by 2, because remember, we're getting half the angle. If you get an angle in the third quadrant and divide it by 2, you're going to get an obtuse angle, right? Because angles in the third quadrant range from 180 to 270. Half of that will lie in the second quadrant, and therefore tan of those angles will be negative, which is why we have this negative here. But realize that our theta 1 minus theta 2 is actually in the first quadrant because it's acute based on our sketch. We are considering the acute angle between the two lines. And so theta 1 minus theta 2 is acute, and therefore half of an acute angle should still be an acute angle. So we are not looking at this case, we're actually looking at that case when t is 1 over 7. And so when t is 1 over 7, that means tan of theta 1 minus theta 2 over 2 is 1 over 7. So we now have, if I were to expand on this, we now have that angle right there, the half, and we have theta 2, so now we can get that angle right there by adding theta 2 and theta 1 minus theta 2 over 2. So we're just going to get the tan of it because we want the gradient. So the tan of theta 2 plus theta 1 minus theta 2 over 2. Again, we're going to use trig here. It's going to be tan of theta 2 plus tan of theta 1 minus theta 2 over 2 divided by 1 minus the tan of theta 2 times the tan of theta 1 minus theta 2 over 2. Now, the tan of theta 2 was 3 over 4, and then the tan that we just got is 1 over 7. So 3 over 4 plus 1 over 7 out of 1 minus 3 over 4 times 1 over 7. Realize it's going to give us 25 over 28 divided by 25 over 28, which is 1. So the tan of our angle is actually 1, which tells us that the gradient of one of our angle bisectors, the angle bisector we're looking at is this one here, because of considered theta 1 minus theta 2 to be the acute angle. So that means that's the angle bisector we're looking at. Its gradient is 1 because the tan of the angle it makes with the positive x-axis is 1. Now, if its gradient is 1, we need a point that lies on it. And we already said that the point of intersection of the two lines, is a point that lies on the angle bisector. So we can find the point of intersection of the two lines by solving the equations of the two lines simultaneously. So we have the two lines already in the form y is equal to mx plus c. So we can go ahead and solve them simultaneously. 4 over 3x plus a third is equal to 3 over 4x plus 3 over 4. I collect like terms for the x's, then I'll have 7 over 12x on the left, and then on the right I'll have 3 over 4 minus a third, which is 9 over 12 minus 4 over 12, which is 5 over 12. So x, when you solve, will be 5 over 7, and then y, when you substitute in any of these, will be, let's try 3 over 4 times 5 over 7 plus 3 over 4. Sorry. And that should give us 9 over 7. So 9 over 7 is actually, so the point intersection of the two lines, which is a point that the angle bisector lies on, is 5 over 7, 9 over 7. So we know that the gradient is 1. So if we use y minus 9 over 7 out of x minus 9 over 7 is equal to 1, x minus 5 over 7, sorry, we should be able to get the equation of the line. So it's going to be y minus 9 over 7 is equal to x minus 5 over 7. And if you arrange this nicely, yeah, you should get y is equal to x plus 4 over 7, which is what we got right here. Yeah, so you can see all we've done to be able to get that equation. Yet you could have got it in that step here. We've done like 1.5 slides of this just to get this equation. It still gives you the same answer, but and I like trig, so I wouldn't mind doing this. But it's pretty long. If you were to do it in an examination, then you'd be taking a lot of time. So I'm not going to show us how we get the other one because of time, but you could still figure it out. The difference will change on what this angle becomes here, right? Because now you're looking at what this angle is going to be. Okay, so now you realize that this angle is the supplement of this angle right here. So their tangents are going to be the same. However, its tangent is not going to be 7/24. It's going to be -7, -7/24. So if you are to consider this large angle here, its tangent would be -7/24. And then when you're finding a half its angle, now realize that a half of that angle there is going to be a different color. We're going to be looking at this angle right here, which when you is vertically opposite this angle right here. And so that angle plus that angle, the angle on the outside here is what we want to find. So when you get that angle, which it will be, you could call this angle, the whole angle alpha. So you could then say tan alpha is -7/24. Then you want to find the tan of alpha/2. You could use the same formula that we used here. Again, you're going to get two angles, one you should consider and one you shouldn't consider. And I think in this case, actually, you'll be considering the negative angle and ignoring the positive one. And then when you get that angle, you want to find the tan of θ1 plus alpha/2, because those two interior angles should give us this exterior angle right here. And that's the angle that we want to find. So tan of θ1 plus θ plus alpha/2. So when you do that, you should get -1. And after getting -1, then you would use the point, which is 5/7, 9/7. Y minus 9/7 out of x minus 5/7 is equal to -1. So y minus 9/7 is equal to -x plus 5/7. Yeah, so y is actually equal to -x plus 2, which is exactly what we got. Exactly what we got here as our first equation. Yeah, so you could also use trig again, that's exact same stuff we did, just that in this case your alpha would be negative, the tan of alpha would be -7/24. And then be careful on which angle you're going to choose when you're solving the quadratic. And then yeah, you should be able to get the same equations that we had got earlier. Yeah, I will not take questions on this. And okay, if there are any questions, then we could have them, but hopefully on the first method and not this one, because it's pretty lengthy. Okay, if there are no questions, then yeah, we have come to the end of the seminar. I hope, please give us your feedback in the form that has been shared. Again, if you're interested in tutoring us, services are available to you. The flyer has been shared, the recording will be shared in the group, the link to the group has been shared. Yeah, continue interacting with us. We'll have another seminar on integration, probably 2-3 weeks from now. So stay tuned for that as well. And have a lovely weekend.